Okay, so let's start. So Scott and I are here to talk to you about how seatbelts for web apps, which are security headers. And we're going to explain to you my weird analogy about seatbelts. We're going to explain to you basically our love of security. No, I'm not kidding.
We might get a bit too excited about this, so excuse us.
Right? We are so excited about security headers. Okay, so like first, the disclaimer. Did you read it?
Oh, were we supposed to read this?
Have you seen this 100 times yet? Because you're going to see it forever. So you've all been disclaimed. Okay, so who are we? So I'm Tanya Janka. I'm known as She Hacks Purple. I'm the head of education and community at SEMREP. They bought my little tiny Canadian company. You will hear my little Canadian accent. At some point, I will say a boot, and I will deny it. I've done a lot of stuff. I wrote a book. I've been in tech a long time. I do secure coding training just like Scott does. I founded a bunch of things. I advise some places. I'm a faculty member. But the key takeaway is that I create a lot of content about security and application security. And I'm very passionate about this topic, just like my friend Scott.
Yep, so thank you. I'm Scott Helm, very similar to Tanya. Got a kind of long history, founded a couple of little projects, Report URI, security headers that Tanya will be talking about soon, which is kind of like where the name comes from. I'm here on the Probably booth as their security researcher and product evangelist this week as well. Been in tech a long time, the vast majority in the InfoSec space. I do training, speaking, blogging, and I like building stuff, which is why I have all these little side projects. So yeah, that's pretty much kind of my history. You know, previously a pen tester, consultant before that, and I was a software QA, probably for sins in a prior life. But I did do that long ago as well.
Oh my God. Okay, so what is this talk about? Okay, so clickbait. So imagine you could secure your apps against tons of different vulnerabilities with just one line of code. Would you do it? Everyone's like, yeah, that sounds good. But yet, when Scott literally looks across the entire internet every day with his things that he built. He literally looks across the whole internet at everyone's security headers. And almost none of you are actually doing it. None of your devs, almost all of them, are not using these things that we're going to talk about today. And they bring so much value. And well, okay, so I'm going to steal your thunder. I'm going to try not to. But basically, they mitigate several types of attacks, and literally almost all of them are just one line of code, and you can just copy and paste. And we actually created a cheat sheet that you can get at the end that you can download, so you can literally just be like, devs, copy, paste. But Scott, are these things like really expensive?
No, and this is the good thing, right? That's so good. This is kind of the main thing for me, is it's all free. So everything that we're going to talk about, there's no tool or product or license or thing that you have to go buy. We're talking about browser native functionality. Built as long as you've updated your web browser in the last kind of 8 years, then the web browsers in front of you will have access to everything that we're going to talk about with no additional purchase or anything required. So native browser functionality that you can access for free.
And if you have not updated your browser in the past 8 years, Scott and I can't help you.
Yeah, there's a prerequisite here.
Okay, so web browsers, historically, like long time ago, they just used to be a portal, right? And you would just look at stuff that was static. And they didn't do very much. So you would just look through them, right? So then, wait, next slide. There we go. So web browsers have changed. So now they do a lot of stuff. Now that it's interactive, things go back and forth. Like when we designed the HTTP protocol, like we were not planning any of this stuff. We were not planning that you would do online banking or buy cute dresses or any of those things that I like to do all the time now, and I'm sure many of you do. And so no longer is it just a portal, but it's an active participant in the security journey.
And on top of that as well, so historically we were responsible for the server. Now with this like new, highly interactive and full-featured browser, we can leverage control of the browser. And of course, everyone's probably familiar with the bit in the middle as well, the transport layer. We're now also responsible for protecting that with HTTPS and secure comms. So if we kind of view, like the distant server off in the faraway land, the transport layer between, we extended our reach there, and now we're extending our reach into the client on the device. So we can now start to leverage and configure and control these security behaviors all the way out to the actual endpoint. So we can now leverage that control of the entire journey. And this is the purpose of these security headers.
Oh, my turn. Oh, no, your turn.
Oh, go ahead. I'll
wait,
take this.
Oh, wait,
It's
wait,
good.
wait.
Yeah.
Okay, okay, so what are web app headers? Okay, so basically, we people that make web apps can tell the browser what to do. We can send it instructions or configurations and say, hey, I'd like you to do this way, show that way. I would enjoy this or that, please. And then was a security header. So a security header is us telling it to do security things for us. So I would like to make sure that all of the communications are encrypted, please. I would like to only allow these scripts to execute and nothing else, please. So just like a security control really just means the part of the code that does the security stuff, a security header is a regular HTTP header, a configuration for your browser that just does security stuff for you. Oh, okay. So,
Oh, our slide broke.
yeah, our slide is not at the right one.
So this is some normal headers. I'm sure everybody's already familiar with HTTP response headers, right? Like we've got the status code up there at the top, content type, things like this. And security headers are no different, right? It's just the key value pair of data that we're sending over to the client, except the thing that we're trying to impact, as you said, is some kind of security control or security function or purpose. So it's just like a catch-all term. All security headers are HTTP headers. That's all they are.
Yes. Okay, so the seatbelt thing, Tanya, why? Okay, so I'm sure that some of you are younger than I am, but like when I grew up, I remember most of us started wearing seatbelts. But if you're older than me, some of you might remember when no one wore seatbelts and that was lame. So people used to not wear seatbelts, and then they died. Not all of them, but quite a few, right? Then we developed seatbelts, a lot more of us lived. And so at first, when we started doing seatbelts, people were like, it's such a pain, it's so difficult. No, it's not, it's really easy, you just do this. Now you get into a car, if you're not wearing a seatbelt, everyone's like, excuse me, I'm not gonna start the car if you don't have your seatbelt on, mister. I'm so like that with friends, I'll be like,
We're not moving.
yeah, yeah. But security headers are the same thing. They do nothing almost all the time, except when there's an emergency. When there's an emergency, when someone attacks your site, the security header protects you. And it's the same as a seatbelt. It's not sexy, it's not a ton of work, but you are
Is it going to crinkle my shirt?
And they don't crinkle your shirts like seatbelts do. So they're even better. And so this is where this analogy came from, because most of the time they do nothing, they don't help, they're like kind of boring, but oh my gosh, they really save your butt. So the dog slide.
Yeah, so as Tanya mentioned earlier, I have a project where I scan the top 1 million sites in the world every single day, and it does heaps of analysis on all different kinds of aspects of the site security, and one of them is the proper use of security headers. So when we say, oh, not many people are using these, that's not kind of conjecture on our part, it's actually based on the data. If we look across the top 1 million websites, usage of all of these things is very low. Usage of some of them is exceptionally low. And they're free and they're easy. So the question is kind of why? Now the biggest thing, when you mentioned you do secure coding trading, so do I, the biggest thing when we talk to people about this is we tell them like, hey, did you know that you could do X, Y, Z? And people are like, oh my gosh, no, I didn't know. And I was like, well, that probably explains why not many people are using them, because there's just not the awareness out there. So we're trying to kind of share this information, promote this material to raise that awareness and hopefully increase adoption. One of them has a tiny bit of implementation complexity, and we'll cover it when we get there. The vast majority of these are what I would refer to as simple, so I don't think this should slow us down too much. Fully backwards compatible, right? So if you have clients coming to your website on like bleeding edge Chromium-based browsers, or Internet Explorer maybe, it doesn't matter. Everything that we're going to do is fully backwards compatible, so it doesn't matter. They're not too difficult to implement, so they shouldn't take too much time. I feel like a lot of these could be implemented as a basic part of a coding standard rather than anything that you actually need to have a conscious thought process around. So hopefully that won't be too much of a problem. The lack of security knowledge, again, I think it ties into the first one really, that kind of lack of awareness side of things. Once we start to tell you how easy and simple some of these are, you'll realize how trivial it could be to increase the adoption of them quite quickly. And me and Tanya are going to fix this one. No one told us to use them. So we're going to fix that. We're going to tell you to use them. And yeah, I think, again, as we go through them, we'll explain what kind of attacks they mitigate. Nothing here is a silver bullet, right? Like, and I think anybody that tells you something is like the universal solution to a problem is usually wrong. They take their place as part of a defense in-depth strategy. So we're not here to give you like the golden answer to all security problems. We're here to layer on these additional defenses.
Yes. Okay, so
My bad.
No. Okay, wait. There we go, the big, beautiful planet.
More
Okay.
AI images.
Okay, so you can't tell, but this is like, I imagine this is like HSTS going around in a beautiful circle. See all those little locks? Those are encryption all around the planet. That's the way me and Scott want to see the planet. So the first security header we wish all of you would use is called HTTP, Strict Transport Security, or HSTS for us nerds. And basically what it does is it just redirects any HTTP traffic to HTTPS. It's like, oh, sorry, you made a mistake. Obviously you want encryption. Who wouldn't? Everyone wants encryption,
Everybody.
including us. And so in this post-Snowden era, everyone wants encryption. And we want encryption to protect our confidentiality, obviously, but also our integrity. We want to make sure what we send is what the person receives and vice versa, right? Especially when it comes to banking. And so if anyone here, has anyone here heard of like the SSL strip attack, like that app that used to just like, anyway.
It's got to be with someone. It's a bit old. There we go. I knew there'd be somebody.
Yeah, but basically like back in the day, and it still exists, there's like this little open source app where it would just strip away, if someone doesn't have HSTS, it's like, cool, I found it, I can get you through, and this means like that angry 14-year-old in their parents' basement going through puberty that has like way too many hormones, that's like really angry at the whole world, can listen to their emo and like see your banking. So HSTS protects us against everyone, including the not so advanced attackers.
Yeah, and it's pretty simple too, right? Like it's just a HTTP response header, so we can see it up here. You just declare the strict transport security header. So we're going to send this information to the client. And the policy that we put inside is pretty basic. So the first directive, as we call it in this policy, is the max age directive, because HSTS has a memory effect. So when we deliver this header to the client, it's going to observe it, but it's going to remember that it observed it for this number of seconds. So that's approximately 1 year in seconds. So what we're saying as the host, so if I deliver this from my website, I'm saying to your client, I now demand and expect encryption. And I want you to remember that I demand and expect encryption for the next 1 year. So if you click a link that says HTTP, if you type HTTP in the address bar, if you have a bookmark that goes to my site on HTTP, your browser will see the initiation of that activity and be like, no, this website said it must be encrypted. So it will catch it and change it before any HTTP comms happen. So that's the sole protection. There are a couple of extra things you can layer on top. Include subdomains, pretty straightforward. If I deliver this on my Apex domain, do I want this policy to apply to subdomains? Usually you do, so usually you would include this. And then the kind of like the cherry on top of the cake is this directive called preload. Now what you can do with HSTS is it suffers with the first access problem. If you've never been to my website, how would you know if I have this or not, right? And like this is what we call it, the tofu problem, trust on first use. And if you've never been to my website, you wouldn't know about this policy because it's delivered in the response. So what you can do with preload, and this is in all mainstream browsers, if you indicate that you wish to be preloaded, the mainstream browsers will take your domain name and build it into their source code. And then, even if none of you have ever been to my website, if you were to go to your address bar right now and do like http://scotthelm.co.uk, your browser would already know about my domain because I'm built into it, and it would be like, nope, you're going HTTPS. So if you want to do that, open the DevTools in your browser, log the network, and try and send a HTTP request to me. I presume nobody's ever been to my website, so you can see the behavior on the first visit. So even if you've never been to a website before, I mean, forget about all the security stuff. Imagine having your domain name built into like 1 billion devices or something, right? Like that's pretty cool in and of itself. That's not why you should do this, but that is pretty cool as well.
Obviously, we've all been to Scott's site, obviously. Okay, so what can go wrong? Everything.
Yeah.
So we can have a man-in-the-middle attack, which means basically someone can see the stuff going back and forth. So this can mean sensitive data exposure. This can mean data integrity issues, stealing cookies. But a thing that I found very interesting is imagine, so back in the day before HTTPS was really quite popular, a lot of the big hotel chains, what they used to do is if you connected to their local Wi-Fi and you went to visit a site without it, they would swap out their own ads with the ads on the page you were going to. And that was a revenue stream for big hotels like Marriott. Imagine,
people get creative when they want to make money, don't they?
Yeah, but imagine you're in a country where the government's not like, doesn't think the way maybe you think, and they want you to think a certain way. Imagine them changing out the news articles. right? Like there's so many things that I think people don't realize. Like there's a lot of opportunity for evil here.
And it doesn't matter if you have HTTPS available, like there's a difference between having encryption available and having it be enforced. HSTS is enforcing the use of it. What we find most people now is that, yeah, everybody has HTTPS, right? Like it's pretty universal, but you need to make sure that people are using it. That's the difference.
Yes, yes.
The Swiss Army knife one. So the next header, this is another security header now, is called Content Security Policy. And whenever I talk to this, I refer to it as the Application Security Swiss Army knife. So it doesn't, like Swiss Army knife, it doesn't have like one, big powerful uber tool. It has lots of things that can help you in various different situations. So this is the way to look at content security policy. Now, when we do talk about content security policy, there's one thing that Tanya will bring up now that is the number one thing that people talk about, and you're going to do it, you're going to talk about the one thing, but remember, there's like heaps of other stuff in CSP as well.
Okay, so the main thing that I love about it is it stops cross-site scripting. Cross-site scripting, boo. I would like to assume all of you think it sucks. I do too, so does Scott.
Still a WASP top 10 threat?
We would like to vote it off the island now. And so content security policy, it is the most powerful tool to stop that. And so on top of that, so how do we basically configure it? So we were told our presentation wasn't technical enough, and that's why we're going over all the configurations with you. You can thank the RSA speaker guide for that. But we also have a PDF at the end that you can just copy and paste, because who wants to memorize configurations? Apparently you do. Okay, so the first thing is like, which scripts are allowed to run on my site that aren't mine? Which ones am I cool with? So where can we load scripts from? Then the next one, actually the next two, are where are we going to send our data to? So when we have a form and we submit it, where is it allowed to go, which domains? And then where are we allowed to connect to? So which sources, like an API that we want to call?
I think that's a really important thing that most people miss with CSP is they view it as the typical control for like loading resources in, and cross-site scripting is the number one thing, so obviously controlling JavaScript. You can also control like images and fonts and styles. They're not particularly dangerous, so we don't often talk about them. But these two, the outbound data component of CSP is commonly overlooked. So where can we load resources? Where can we send data out of the page? Now your login form probably should only send the post to one place. If you've got JavaScript doing external comms, you can probably control that quite tightly as well. So yeah, that dual in and out aspect of CSP is very important.
So you might be thinking, oh no, what if I break my site because I forgot something? That's why there's the report URI section. And so Scott has a company where basically like you can get him to make you beautiful reports, but basically there's a free feature inside of it where you say, send my report to here. So you turn it on alerting mode or reporting mode, and it just tells you, I would have blocked this, I would have blocked that. And so you keep tweaking until it's like, you're cool. And then you turn it into blocking mode. And so we've got you, we're well aware, we don't want to break any sites.
Yeah, like you can break stuff, it's powerful. And I think it was it Spider-Man? With great power comes great responsibility, something like that. And yeah, like there's no reason that you should break anything. There is the capability, like you said, with alert mode, report mode, to get the feedback from the browser. And remember, this telemetry is coming directly from the client. This is a browser feature. There's no software, no agent. This is browser native. You can send it the policy, and it will send you a report back and be like, oh, if I were to enforce this policy, I would have done X, Y, and Z. And you're like, oh my gosh, it would have blocked all my images. Oops, we best go add those images to our policy. So you can iterate safely.
But Scott, aren't there other features like trusted types?
Yeah, so as you can kind of it's basically like an SBOM. It's like super cheesy, I love it. It's kind of like an SBOM or a manifest file for your web app, right? And people in mobile development scenarios will be familiar with these kinds of things. So it's kind of like the same thing for your web app. And CSP version 1, which is 10 years old this year actually, was kind of basic. Version 2 and version 3 are now widely standardized and supported. And there are new features layered on top of these controls that give you a lot of flexibility. So, for example, if you want to load script from like 27 domains, which seems to be about the average, you might not want to maintain the list of 27 different domains. So instead, there's a feature in CSP where you can just tag script tags on your site and say, these are the authorized ones, like if I put this special tag on them. So it's an attribute that you put in the script tag. So there are like, if you look at this and think, oh my gosh, my SBOM, my manifest is going to be enormous, there are more effective measures now to simplify that for you. But ultimately, it's just taking that little bit of responsibility, keeping that like manifest, that SBOM, and just saying, I know the stuff that's supposed to be on my site, and then you give that to the browser and say, if you see something else on my site, please tell me, because it's not supposed to be there.
Absolutely. Okay, so, actually, do you want to tell us what can go wrong?
Yeah, I can keep talking. Sorry, I'm just going to like roll straight through.
Just
But
do
yeah,
it.
the cross-site scripting thing, OWASP top 10 threat, still, it has been forever actually, hasn't it, as
Over
well?
20 years.
So yeah, like it's the number one most dangerous thing that CSP can fix. Therefore, if you go away and do some Googling later about content security policy, you're always going to see it talked about in the context of mitigating cross-site scripting. But just remember, it can do a bunch more stuff than that.
Like?
Yeah, like I think the question really for what can go wrong if you end up with foreign JavaScript in your origin is like, well, how good are you at writing JavaScript and how evil is your imagination? Right, because that's the limit on what an attacker can do. If it's, I mean, we see recently with MageCart and other hacking collectives, they're targeting very simple keyloggers. It's like 4 lines of JavaScript, and they're targeting payment pages. So you sit there on a payment page, right? You type in your full card number, the security code, your address, and the JavaScript is just reading those keystrokes off the page, Ajax out the back, and it's a full-blown keylogger in like 4 lines of JavaScript. So in terms of the sensitive data and things like that, the question is, what does your site handle, right? Because if you don't handle card data, you're not worried about card data, but you might handle health data, so you'd be worried about that instead. But yeah, there's nothing good that happens.
Yes. So you're probably thinking, oh, this is so easy, right?
CSP, just create a list of things.
But so we want to look at the reality. So some people have some feelings about this, including Ben Affleck. So we want to address some misconceptions about content security policy header, because when we introduce it to developers, sometimes they're like, yeah, that's that thing that broke my site, you suck. Okay, so some people are like, what about lack of consistency across browsers? It is made to work with other browsers. It is made where if the browser doesn't support it, it does not break the site. If you are using Internet Explorer, I'm so sorry, but also you're gonna be okay.
Please update.
Yeah, please update, right? You're probably having a very bad day. But it works across all the different browsers. It should not be breaking anything. Compatibility, header conflicts. So you can stack all these headers on top of each other. They're made that way on purpose. They should not be conflicting at all, especially content security policy header. So they're made to work together. So you're not like, oh, I have to choose this one or that one. You can have as many security headers as you want. There's no compatibility. It doesn't matter what programming language, what framework you're using. It works with all of them. Performance hit, there should be no performance hit with any of the security headers. And maintenance and updates. Again, like as the security headers are updated, all of the browsers change and they make sure they're backwards compatible. They don't want you to go to a new version of Chrome and then everything in the world breaks for you, right? They're well aware of that. They know that that would be the end of the world for many people. And so we plan for this. And by we, I mean me and Scott just tell everyone.
That's the royal we.
Yeah, the royal
everybody else
we.
does it.
Yeah, and so please don't disappoint Ben Affleck, in summary.
Yeah. I think, like looking, the CSP at scale thing now is kind of like my next point as well, in that, you know, HSTS is basically set and forget. The other upcoming headers shortly are also set and forget. CSP is the only one where you're going to have some like real consideration around how we do it, especially if you're operating at large scale, because essentially it's a manifest file for your web app. And if you're managing 100 web apps, they probably share maybe a lot of their third-party dependencies in common, but they're also going to have usually some unique components. And unfortunately, that will mean like one policy per application because it has its own unique set of components. So at really large scale, this does become difficult. I generally find, because at Report Your Eye, like we deal with huge amounts of enterprise customers deploying CSP, the really hard part is retrofitting it to an application, right? If you're doing this on a greenfield site and you're rolling in with CSP from the beginning, this is so easy to do along the way. But 99.9% of us already have existing web apps and we're going to have to retrofit it. So that's where the effort, this is the only one that requires that little bit of effort. But I think we should probably know and have like a list of our JavaScript dependencies, like who can run code on our website. I don't think that's an unreasonable thing to ask people for, right?
Imagine an accountant or like a finance department that's like, oh, I don't keep track of all the corporate credit cards because that's so much work. Would that fly?
We should probably have the basics in place, right?
Yeah.
Like, we should probably have some basic oversight here. The report-only feature will help you with this. So this was the safe kind of test mode, alert mode that we talked about. You can deliver the policy to the client. It will give you the feedback and say, I would have blocked, ABC, X, Y, Z. And you can look at those things and be like, oh, yeah, those are legitimate dependencies. We'll add them to the policy. And this is how you kind of iterate and build. You can do this very quickly. Don't think that you have to go out there and like crawl through your code base and try and find like every JavaScript dependency and image dependency. You can use CSP to do this. So you just deploy a policy in the safe test mode, and it will give you back a list of all the things it would have blocked. That's your SBOM right there. And then you just go through it and see, are those all expected and intended? So don't think that you have to like scrape your code base or crawl the application and pull all the dependencies. You can do this with minimal effort.
And lastly, what we're doing right now.
Yeah, I think this is probably the number one thing. We've just got to raise awareness about this. The good thing is, if any of you are like kind of compliance folks, PCI DSS 4.0 became like recommended from March this year. It becomes mandatory from March next year, and the PCI SSC would never tell you that you have to use a particular thing, but the new requirements about ensuring that all JavaScript on the payment page is authorized using a technical measure, they're very clearly hinting at CSP. And actually, if you read the guidance column, it says we recommend content security policy, because this is the perfect mechanism to make sure that JavaScript on your site is authorized to be there. So we'll get there.
And the rest,
but everything else is easy, we promise.
Yeah, the rest of them are all just one line. Okay, so the next one's permission policy. And so this is which permissions in HTML5 are allowed on your page. So can we see the camera? Can we turn on
like the microphone for Zoom or something, right?
Yeah, exactly. And so if you're using Zoom or Teams or something like that, it makes sense to turn on the microphone. But if you went to one of our blogs and it wanted to turn on the microphone and camera, you'd probably be like, Scott and Tanya are pretty creepy. Why do they want to watch me read their blog? Creepy, right? So this is you implementing least privilege on your site. That's it. So let's look at the configuration. It's really easy. Do you want to tell them about it, Scott?
Sure. So again, just another single line HTTP response header called permissions policy. And you were talking earlier about how advanced web browsers are now. Like the things that you can request access from, we've got like camera, microphone, geolocation, probably like the really privacy kind of creepy invasive ones. We got the payment intents API here. You've got like potentially access to USB, Bluetooth, files on the device. Like there's a heap of powerful things that you can ask for permission to do as the web app. Now on my site, pretty much your site as well, like I'm really confident that I never want to look at your camera.
No offense.
But I can if I want to. However, you implement the permissions policy, and here we have the list of domains of origins that is allowed to request permission for the camera, and it's an empty list. So what I'm basically saying is, look, I don't expect to ever request the camera permission from the user. But I might have like a comment section on my blog. I might have adverts that are running JavaScript. I might have things that I iframe and bring in. And those could also request those permissions. Now to the user, it's going to look like, well, I'm on Scott's site and it's saying Scott Helm wants to access your camera because one of my dependencies has requested the permission. So we can give this like whole least privilege approach and just say, right, I expect nobody to be able to request the camera permission. So now if something tries to, it will be blocked and the user won't see the permissions pop up to say, please can we look at your camera? So it's one of those things like 99.9% of the time this probably won't do anything, but it's just making that statement to say, well, we don't expect to access the microphone or the geolocation of the user. So say that, make that statement and actually define the list. And this is my list here. It's like nobody gets to access the camera of people who come to my website.
To be trendy, we are applying zero trust to the permissions. And so what could go wrong? Like if you have cross-site scripting in combination with this, well, and someone turns on the keylogger, the
Just
webcam.
imagine like if you have that JavaScript in your site and they can request access to all of these permissions. If somebody's running JavaScript in your origin, they can ask for any one of those really powerful features to be enabled. That's not going to look good, is it?
Yeah, we were actually talking about, so like I live near Victoria, BC, and I drove downtown and I'm like going to park my car, I'm all excited. And then I downloaded the parking app and it said it wanted to see my photos, it wanted to see my contacts, and it wanted to be able to make phone calls on my behalf. And I was like, no, City of Victoria, you may not. And I tweeted at them and they said, please read our privacy policy. I'm like, it sucks.
How about just don't ask for them?
Yeah, so then I actually had to park in private parking because I just refused to allow them to see all of that. I'm like, this is ridiculous.
But it's a good point though, because most people are probably familiar with the concept of installing an app, like a native iOS or Android app, and it shows you the permissions. But when you go to a website and you load a web app, those are all kind of implied that you accept. And yes, you'll get the little pop-up in the corner, but we know that historically people are not great at fully understanding and reading and agreeing to pop-ups. So it's not a foreign concept in the native mobile platform. We're bringing it to the web platform.
But what about astronauts, Scott?
Yeah, there are way more security headers than we've talked about, and I think we could actually do like a whole day on this, but we're not going to. So we're going to do kind of like a rapid fire round now. We've talked about the ones that we feel should definitely be at the top of your list, and now we're going to do like rapid fire brief introductions to many of the others, just so like you might hear one and think, oh, that's the one that sounds most relevant to me. I'll go away and read about this one. So yeah, let's have a look. What do we got?
Okay, so first we want you to implement HSTS. This is making sure that everyone always connects encrypted to your site. Next, we would like you to use content security policy header so we can just stamp out cross-site scripting for good. Then we would like you to start with permissions policy and apply the zero trust to all the permissions, like we said. Then we'd like to do referrer policy, which has more to do with privacy, because basically it says, you don't get to know where I just came from. So let's say you were at extremely embarrassing website / way more embarrassing page.com. You can say, I'm not going to say where I came from, or I'm not going to let you know which page I came from. And so let's say you run a medical site. It's none of anyone's business to know that they were, accessing benefits, or that they had a massage, or whatever it is that you do. This is you protecting their privacy, and privacy is really important.
And I think most people will probably, like again, in my experience talking to people, most people, like when you navigate from one page to the next page generally knows the page that you came from. And that's fine if it's like within the same site, but if you navigate externally and go to a different site, the different site generally gets to know where you just came from. And referrer policy controls, like, are we going to send that? And if we do, how much information? Usually the answer is none, please. But yeah, like it's just a really, to me, that seems very not logical. Most people would not think, oh, if I go from this site and I click a link and go to this totally different site, it will tell the totally different site where I just came from. It doesn't seem like a great idea, and we should stamp it out with referrer policy.
Yes, exactly. So the next one's X-Frame options, and this is backwards compatibility. So content security policy header replaces it, but lots of people still have older browsers that don't fully support content security policy. And so what this does is it says, please do not frame my website, or only this domain may frame my website. Most of us don't want our websites to be framed, and if we do, we're usually like, not everyone is allowed to.
It's a pretty elite club.
Right, it's a pretty elite club. And then the last one is X content type options, and this one specifically stops MIME sniffing by the browser. So basically, resources can't be interpreted as the wrong type. So if it says it's an image, it's not data. And this just avoids certain vulnerabilities and just makes life better, and it's one line of code. But Scott, there's more.
Yeah, so I can click, it's fine. The ones on the previous slide I would say are like the essentials. Those are definitely the things that you should tackle first. You can change the order to suit your kind of like desires and your specific circumstances. The ones now are definitely like the more advanced end of the scale, right? So you unless some of these are super applicable to you for some reason, these are probably going to be much further down the road on your journey. So these are all like the C-based headers. There's quite a few of these that are coming now. So we have like COEP, co-op, and corp. And these are all designed around controlling when you load resources into your origin, into your page, how should they behave and how should they act together. So COEP and co-op are going to be going onto your own page, and if you self-host some assets like JavaScript and things that you load in, then you will be responsible for putting the corp header onto those assets. So if you're loading JavaScript, it should have the cross-origin resource policy header defining how it behaves. The big problem that you'll have, like COEP and co-op, you're putting these on your own site, your own assets. This is easy. The big problem that I see people come across is if you're loading third-party Java, like who loads third-party JavaScript, right?
Everyone.
All the people with their hands down are lying. So everyone loads third-party JavaScript, right? The big problem that you're going to have is hopefully your CDN provider or the library provider or whoever, they have to set the corp header on their assets, and obviously you don't control that part. So at the minute, this is the big thing that we're kind of waiting for, is nudging and pushing these organizations to be like, please add these new headers, and then when we load your assets, we can enable these additional controls. And it's all around trying to isolate your origin within the browser itself. I'm sure everybody saw like the Spectre Meltdown attacks that made really big headlines recently. Like, it's
recently in 2018.
Yeah, well, it's like before COVID, so I've lost all context of time before then. But if you correctly set up all of these controls and features, you get the protection called corp, which is cross-origin read blocking. So one of the whole big issues with Meltdown was that if a user loads your page in their browser and then they open another page, the same origin policy prevents them from accessing data from one origin to the other. And potentially, with Meltdown, you could break that barrier, and just by the user having another tab open with another site, they could potentially read that data across the origins. So if you get these first three set up correctly, the browser will give you CORB, cross-origin read blocking, and your site will be totally isolated in its own context in the client. So none of those attacks would have been possible. So of course, these have all come around since those attacks. So very specific, very kind of, definitely towards the end of your journey, all of the other security headers should come first. You'll see a lot when you read about CORP especially. You'll see a lot around CORS, the cross-origin resource sharing. This has been around for a really long time. However, CORP it's like CORS++, right? It's like the next step. It's like an additional protection there as well. So yes, even if you are using all of your assets and loading them properly and CORS is configured properly, I would still say you definitely need to consider CORP and COAP as well. So yeah, they're definitely like way more on the advanced end. Like this extra header, there is a lot here, right? So definitely previous slide is your number one list to tackle. This slide here, much more down the road.
Okay, so now we have forbidden headers. Headers we do not want you to use. So we as an industry are trying so hard to do a good job, but sometimes mistakes have been made, and so we would like to help you avoid accidentally making a mistake. And so the first one's the super scary one. Do you want to handle this one, Scott?
Yeah, so HPKP, as it's known, is, because if you go out there and start Googling about security headers, you're going to come across these because they are security headers, but HPKP is now deprecated. It was a mega powerful feature, but it was super complicated to configure properly. And if you configured it wrong, it could result in the browser refusing to access your website. And unfortunately, this happened quite a few times, and in the kind of discussions group at the standards bodies, like a term was coined, like HPKP suicide, which is when you kill your own website with HPKP because you misconfigured it, and the browser will just flat out refuse to connect to your website. So it was mega, mega powerful. Like the Spider-Man thing I said before, with great power comes a great responsibility, and if you screw around with it and mess it up, you could literally tank your whole website.
For a year.
Yes, for a year. For the
It-
duration of max age, just like HSTS before. So this was deprecated and removed. So if you start looking around and reading about security headers, you are probably going to come across this. Know that you should not use it.
Yes, please don't. So the next one is XSS protection, which Scott and I worked towards killing. So it was very immature, not very advanced protection against cross-site scripting. It would only protect against like ridiculously obvious attacks that were just totally silly. And so it didn't offer that much protection, and it was like, okay, fine, it's replaced by content security policy header. It's not that mature. But then someone figured out that they could attack the header. So the header has like a little auditor inside, and they figured out if they sent certain types of requests that they could get the auditor to break the JavaScript of your site, so then your JavaScript wouldn't load, then your site looks like crap, and then you've been attacked, right? And so because it causes risk, and that attack's not that common, but we don't want your sites to be damaged, and it offers basically no protection, and so just please don't use that one. It's not the end of the world. If you do see a vendor that is reporting it, that you're supposed to be using it, please email them and tell them to grow up.
Yeah. If you look, like 99% of sites that use this now have it set to just 0, which disables it in any browser that might still support it.
Mm-hmm.
So you might come across it a lot, but the 0 value just means please disable the auditor because it can be tricked and abused, as Tanya said.
Mm-hmm.
The next one that you'll come across, Expect CT. If you find this was just a stepping stone for a transitionary period. It was basically a requirement that was introduced at the back end of 2018 for all websites. And prior to that, you could use this header to see, is my site ready for the new requirements that are coming? So you could enable this header, get that feedback from the browser like we talked about earlier, and it would tell you if you had any problems with CT as the certificate transparency requirements. So you could basically find out, come the deadline at the end of 2018, will my website work or not? So you don't need to use this on anymore. All of the requirements of certificate transparency are already applied, so you will already know if your website doesn't work because it won't work. So you don't need to set this one anymore either.
Now for the cutest AI generated image. Okay, so you might be thinking, what do I do? Where do I go for more information? One of the best things about this industry is a lot of us love to share information, and Scott and I have a whole bunch of resources for you, so you might want to get out your phone. So Scott, I would like it if you would tell us about your cool website. This is how we met. I used this website. Actually, someone shamed me with this website.
Yeah, that happens a lot. I'm sorry.
Yeah, and someone was like, you got a D on securityheaders.com. And I was like, oh no. And then I had to add security headers, and I was like, actually, this is really nifty. And then eventually Scott let me be his friend.
This was, gosh, I think I founded this, it was like 2013 or something. And I was getting into the whole security headers thing. It was like becoming really popular. Security headers were becoming really powerful. And I'm constantly doing like call requests and parsing headers. I was like, I want a simple tool to tell me, is this web app doing headers? Which headers is it doing? Is it doing them properly? So you can go to securityheaders.com. You can punch in your site. The scan takes like 2 seconds because it's one HTTP request, and it will show you which of the recommended security headers are you using and not using. It will give you information on the ones you're not using so you can read more, and it will also look at your configuration and grade your configuration. So yeah, super quick, super easy. Please view this more as an education tool. Yes, it has a grading system. It's a bit of fun for a challenge. It's not a security auditing tool.
And OWASP.
Oh yeah, the Secure Headers project as well. OWASP always has great resources for everything, so you can always rely on OWASP to have something good.
We love OWASP. Okay, so the next one, so I work at SumGrep, and I made a security header cheat sheet. So that's what that QR code is. I promise I'm not going to hack you. Basically, you
Click
go
my
there.
link, it's fine.
Yeah. Click our link, it's fine. So basically, it is a couple pages of PDF where it just says, this is what this does. Here's the configuration we suggest. And I put them in the order that I like. You may use any order you want. Please use it. Also, and there's the bit.ly if you feel like typing. Also, awesome people. There's so many awesome people.
I think we just kind of like took a few each. People that have really driven these standards forward at the browser vendors, because of course the browser vendors have to implement this stuff. People like us that talk about them, blog about them, publish free information, useful tools. So yeah, we just like kind of grabbed a couple of people each that we thought it would be worth giving a shout out to.
Yeah, and Troy's our friend, and we need to make fun of him. Okay, so the apply what you have learned today slide, the mandatory slide, you've all seen this. Okay, so next week you should identify which security headers you should start using. It's HSTS and CSP.
Yep.
Then in the first 3 months you should
deploy those.
You should start doing those. This is our opinion. You don't have to do what we say. We're more like halfway begging. We'd really like you to use them. Within 6 months, ideally, you should add security headers to your coding standard. You should establish timelines for the remaining headers. Like we really, just a second, let me go back. We really, really, really would like you to start using them. And I know we've said this like 5 times, but Scott and I teach all the time, and we never see almost any. And people are like, oh, wow, I've never heard of that. And so we are trying so hard to get the message across. We're going to make a course online and put it on the internet for free. Like, we really want you to start using them. Okay, I'm going to stop.
And I know that it's kind of a little bit like back to basics, right? And it's not the most jazzy subject or like, ooh, wow, flashy, super cool hacks. I'm sure there's some like fantastic talks and presentations about like super forward-thinking things here. And we are kind of, a bit like, let's go back to the basics, right? But we always have to get the basics right before we start building things on top of a poor foundation. So yeah, like we appreciate it might not, have the most like cool appeal because they're not like super elite kind of cybersecurity research topics, but we've got to get the basic stuff right first. So yeah, the goal is like, we want to make them like seatbelts. I know we keep saying it, but like you'll just get into your web app, you'll click, and you just do it without thinking about it.
Okay, so remember, all of us are here at RSA doing our jobs because we want to protect our users. We want to protect our citizens. We want to protect our colleagues. We want to protect our friends. We want to protect our families. That's why we're here. That's why we do this job. It's not just to protect our apps and our butts. It's because we do noble work that really, truly matters. Like, I don't know how to explain it, but I feel the work that people in security do really, really matters. We're protecting others. We are doing good work. And so this is their data. This is their information. This is their lives. And it's in our hands. And I know I sound all tense or whatever, but I am. They are the ones that suffer the consequences when we don't do the work. And so please consider that. And with that, we have some free resources for you. So I have a blog, Scott has a blog. I opened a free academy last week, academy.sungrep.dev. It's all free and it's gonna remain free with tons of lessons, and me and Scott are gonna make a course, yep, that's right, about this.
Yeah, that will be the full day if you want to do a full day on security headers.
Yeah, if you want to test, like content security policy header, go to report-uri.com and it'll show you like what your CSP is doing. Or you could write your own, but I mean, you could also be lazy and use it like I do. With that, so
yeah, I think we're good.
Yeah.
Just hopefully people got a picture of that. The video and the slides will be available later, and you can find us both on Google as well.
yes, questions. Thank you. Thank you very much.
Thank you very much.
Thank you. Thank you. Please come up. There's microphones, so you first.
Hi. So I don't know if anyone can hear me.
Just a bit closer into the mic, sorry.
You're tall.
Let's see if I
Mike's
can do
short.
this.
There we go.
Yeah, so it's a little bit better. So may I ask a difficult question?
Yes, please.
And I don't do this lightly, given the fact that I use securityheaders.com in
Okay.
my job. It's actually, it was a big pleasure for me to meet you. But the question will be very difficult.
Okay.
So can you please tell me, what was the decision-making process preparing for this conference, RSA, when you decided not to include Frame SRC directive for CSP? In my opinion, that is the most important directive for that header, because that's the only thing which would stop keyloggers.
Yeah.
So, because as you said, you have you do this quite often, and I thought that would be important for me to bring attention to this,
Sure.
and maybe you would be willing in the future to change
add.
this a little bit and include this. And there is actually performance impact for that particular one if you are, for example, provide services to a software as a service provider who provides services to thousands of their customers. Then you will have to list all of those FQDNs in that tag.
Oh, so
Tens
just to
of
make sure I
thousands
understand the
potentially.
question, so for the performance thing there, you're saying basically the size of the header in the response. Was that the performance impact that you meant? Or were
Yeah,
you
to me the most important thing is the first one.
yeah,
But the second is, I just kind of mentioned because I
the
ran
performance
into
thing.
this.
No, for sure,
Yeah.
they're both valid points. So
Thank
yeah,
you.
so we showed like a super brief list of the CSP directives, and kind of like going back to the Swiss Army knife analogy, depending on your circumstances, like one of those may or may not be more important, depending on what your application does and how it works. Frame source, yeah, super important, especially in the context, again, of the new PCI DSS regs. If you're embedding your TPSP's iframe in the site, you need to control that. So it wasn't so much like we think that script source is the most important or something. It's more just we wanted to have representative examples of the directives that control data in and data out. And with a small slide, we don't want to like overwhelm with the 40 directive list or something. Something had to make the cut and something had to not. So don't read into it as kind of like our view on the most important ones. We just cherry picked some examples to show you. To answer your second question on the performance side of things, yes, like if you have a content security policy declared, you're obviously returning bytes in the response header, and ultimately that's data on the wire. Hopefully, given like vast majority of applications should be running HTTP2, if you have HPAC compression on the headers, I would probably say like if you're worried about the few bytes of data in the header, you must have licked like every other performance concern in your application. So yeah, like you're 100% correct. There are bytes on the wire, and we can't avoid that, but I'm not sure that you could measure the performance impact of those bytes in a meaningful way. But I take your point, like it's a fair point.
Thank you.
Hi. So just a quick question. With HSTC, we know there's some privacy concerns. So what do you say to people that are more in the cloud, so that don't care less about man-in-the-middle attacks and more about the privacy concerns which HSTC comes across with?
Do you mean HSTS?
Sorry, HSTS. Sorry.
What would the privacy concern be? Sorry, just to make sure I understand the question.
Yeah.
You can track someone from a visit to all the
So the
different websites.
HSTS
yes.
super cookie thing.
Yeah.
Yeah, so Chromium did some excellent research on this, and I'm pretty comfortable now that like it was coined the HSTS super cookie. I'm pretty confident now that the impact of that is negligible. Like they've done some really good work. And for people unfamiliar with this, basically you can set HSTS or not. So if you have like 255 subdomains, you can set HSTS or not on those 255 subdomains, and that would give you essentially like a bit mask to identify users by setting HSTS on a unique combination of those subdomains. So Chromium did a lot of work to mitigate the impact of that. And I would say now, I'm happy that the impact is not anything to be worried about. Good question though, yeah. The super cookie thing was really interesting research.
Thank you.
Great, thank you.
I think he was first and then you.
We'll do everybody. It's good.
Yeah, thank you. I just wanted to ask, what about sites behind a web app firewall or WAF? Is there any considerations there, whether when you're scanning the security headers, how that enumerates behind a WAF, or just, I guess, these policies in general? Is there any kind of things to look out for?
Yeah, there's like two. Sorry, can I take this one?
Yeah.
Is that okay? Sorry to jump in there. Yeah, so I guess like there's two angles that you could look at this. You've got the deployment considerations. So where you set these HTTP response headers in your infrastructure doesn't matter, right? Like you could do it in server config, Nginx, Apache IIS. You could do it in your application code because that can set headers. Or I see loads of our customers, they set their security headers at their WAF, at their cloud edge provider. So you can go into like Encapsula or Akamai Cloudflare and be like, please add these response headers to all of my responses. So in terms of the setting and deploying, do it wherever it suits for you. Like it's no problem at all. And then as soon as the response has left your control and is on its way to the client, it's just a HTTP response, and the browser will treat them all exactly the same. So in terms of after you've deployed it, you're good. Do it whichever way is most easy for you.
Awesome, thank you.
Thank you.
Okay,
Oh,
sorry
okay.
about that. We'll take the questions from the remaining people. We'll step over to the side and let the next people come in.